Hi, my name is Christina Martine, and today I'm going to be your host for this mathematics video brought to you by RJ. Today we're going to discover how to calculate a Vieta vector. The term Vieta comes from the mathematician Francois Vieta, who worked with roots of polynomials. So what is a Vieta vector? So here we have the definition. A Vieta vector is a vector whose entries are the sums of the products of elements within subsets with the same cardinality in a power set. Let's do an example. The perfect example is Euler's identity. So to calculate a Vieta vector, we need a set of elements. And Euler's identity includes 5 wonderful numbers: e, pi, I, 1, and 0. S equals e, pi, I, 1, 0. We will use this set of 5 elements to calculate its Vieta vector. So now we need to determine the power set of this set, which is the set of all subsets of the set. However, to be more efficient, I'm going to combine this step with the one after, which is dividing the power set up into the cardinalities or sizes of its subsets. I will use a subscript to denote the cardinality. So P0 and P1 and then we'll move on to P2. And for P3, And for P4, and then finally for P5, so now we need to find the product of the elements in each subset of these and make them entries of a vector instead of a set. This is because sets cannot have duplicate elements, and it's quite possible there could be a duplicate product. We will define the product of an empty set as 1. So P0 would then be 1. P1 would be E pi I 1 0. P2 E pi EI E 0 pi I pi 0 I 0 0. So as we can see in P2, there are duplicate products, the zeros. So P3 then would be E pi I E pi 0 EI 0 0 pi I 0 0 0. P4 would be E pi I 0 0 0 0. And P5 would be 0. Then we sum up all of the entries in each vector to produce a number. So S0 would be 1. S1 would be E plus pi plus I plus 1. S2 would be E pi plus EI plus E plus pi I plus pi plus I. S3 E pi I plus E pi plus EI plus pi I. S4 equals E pi I. And S5 would be 0. Finally, we put these values inside a vector in the same order. V equals 1 E plus pi plus I plus 1 E pi plus EI plus E plus pi I plus pi plus I E pi I plus E pi plus EI plus pi I E pi I 0. So this is our final product here. And now we've calculated the Vieta vector for the set of numbers in Euler's identity. So the entries in the Vieta vector are the coefficients for a polynomial where the elements in the set are the roots. I hope that you enjoyed this video, and thank you so much for watching.